KURINJI Senior Secondary School, CBSE, Numerical.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, we start with problem number 22 in this class. Okay, see here, ma. Right? First, see the first problem number 22. See here, an electron gun with its anode at a potential of 100 volts fires out electrons in a spherical bulb containing hydrogen gas at low pressure. Low pressure means it is what? 10 to the power of minus 2. 10 to the power of minus 2 mm of Hg. Okay, full stop. A magnetic field of 2.83 into 10 to the power of minus 4 Tesla curves the path of the electrons, right? Curves the path of the electrons in a circular orbit of radius 120 centimeters, right? Determine E by M from the data, right? That is what he has given. Okay, see here. So an electron gun with its first try to understand the problem. Already I read the problem, but once again I will explain you what he has given and what he is asking to find. Okay, see here, an electron gun with its anode at a potential of 100 volts fires out electrons in a spherical bulb containing hydrogen gas at low pressure. That value also given 10 to the power of minus 2 mm of Hg. Okay, so this is the situation what they have given. But in this situation we got one value, that is what? Potential 100 volts. Potential V is equal to 100 volts. Fires out electrons in a spherical bulb containing hydrogen gas at low pressure, 10 to the power of minus 2 mm of Hg. Full stop. A magnetic field of 2.83 into 10 to the power of minus 4 Tesla. A magnetic field of 2.83 into 10 to the power of minus 4 Tesla curves the path, right? Curves the path of the electrons in a circular orbit of radius 12 centimeters. It is what? 12.0 ma. 12.0. So it is what? 12 centimeters. See here, R is equal to 12 centimeters we have taken, right? Determine E by M from the given data, right? So this is the data they have given. What is the data they have given in this problem? First, potential, that is what? 100 volts, and this is what? The radius of the circular orbit, 12 centimeters. You can write in meters, 12 into 10 to the power of minus 2 meters. And the magnetic field 2.83 into 10 to the power of minus 4 Tesla. Okay, so 3 values they have given if you search. Okay, and from this data he is asking to find E by M. That is what? Ratio of charge to mass, right? See here, ma. The gain in kinetic energy of an electron, the gain in kinetic energy of an electron when accelerated through V volts. When accelerated through V volts is see here. So it is also energy and it is also energy. So that we are writing half mv square is equal to EV, or just we are writing V square as subject ma. V square is equal to 2 into EV by m. Okay, V is the potential difference. V is the potential difference or potential, and this is the speed. Okay, it is like a small v and it is like capital V. See here, right? So V square is equal to 2 into EV by m. It is like equation number 1. Now, as magnetic field provides centripetal force to the electron, we can write EVB is equal to mv square by r, mv square by r, and this is also speed and this is also speed, so that you can get cancelled, and finally here you will get it as V is equal to EBR by m. From this only we are getting this r, OR, V is equal to EBR by m, comma, we are squaring on both the sides ma. So V square is equal to E square, B square, R square divided by m square. It is like equation number 2. So it is also speed, this is also speed, but this is potential difference. Okay, see here, potential, right? So from equation 1 and 2, left hand side is same. Here also V square, here also V square, and right hand side also, if left hand side is same, you can equate right hand side, no? So from 1 and 2, right, 2 EV by m is equal to 2 EV by m is equal to E square, B square, R square by m square, right? So this is m, this is m square, so you can get cancelled, and here m is the remaining, and here E square, so you can get cancelled E here only one E is available. Now E by m is equal to 2V. See here, that is what E, and this is m. E by m is equal to 2V by B square R square. E by m is equal to 2V by B square R square. Okay. So that is equal to 2 into 100 divided by, this is what BM, 2.83. We have written here clearly 2.83 into 10 to the power of minus 4 Tesla. That is what magnetic field we have to substitute, and then R value is 12 into 10 to the power of minus 2 we have to substitute, and it is B square, it is R square. Then finally if you complete this calculation, we will get the answer as 1.73 into 10 to the power of 11 Coulomb per kg. This is what charge to mass ratio, whatever he is asking to find, that we found, and we got it as 1.73 into 10 to the power of 11 Coulomb per kg. Okay, right. So in this problem, by giving certain values or certain physical quantities, he is asking to find charge to mass ratio, that we calculated, right, by using this formula. And how we got this formula, that is also important. So first this is like equating energy, we are getting equation 1, and then from this, that is what based on the situation we got this one, and from 1 and 2 we got the formula. Substituting the given quantities in this formula, we are getting E by m value as 1.73 into 10 to the power of 11 Coulomb per kg. Right, now next problem, right, that is what problem number 23. Next problem, see here, an X-ray tube produces a continuous spectrum of radiation with its short wavelength and at 0.45 angstrom unit, 0.45 angstrom unit, full stop. What is the maximum energy? What is the maximum energy of a photon in the radiation? What is the maximum energy of a photon in the radiation? Okay, right. See here. So in this problem there are two things, 1 and 2. Right. The first thing is, an X-ray tube produces a continuous spectrum of radiation with its short wavelength and at 0.45 angstrom unit, full stop. What is the maximum energy of a photon in the radiation? This is what one. And second one, from your answer to A, guess what order of accelerating voltage? Guess what order of accelerating voltage in the bracket for electrons. Accelerating voltage is required in such a tube. Is required in such a tube, right? From your answer to A, guess what order of accelerating voltage is required in such a tube, right? Now see here, first we have written the given things, that is what 0.45 angstrom unit, right? Short wavelength, that is what 0.45 angstrom unit. So when it is 0.45 angstrom unit, here that is what if you observe carefully, 0.45 into 10 to the power of minus 10, 0.45 into 10 to the power of minus 10 meters, right? Lambda minimum is equal to 0.45 angstrom unit is equal to 0, just we are converting angstrom unit into meters, right? That is what here 0.45 into 10 to the power of minus 10 meters, okay? Afterwards, we are going to calculate the maximum energy of an X-ray photon. The maximum energy of an X-ray photon. Okay. Then what is the formula here? See here. That is what the maximum energy of an X-ray photon is. So E maximum is equal to H nu maximum. Right? E is equal to H nu. We don't know. So E maximum is equal to H nu maximum, that is equal to Hc by lambda minimum, Hc by lambda minimum, and write down the values of H and C, and then lambda value, that is what H value is 6.63 into 10 to the power of minus 34 into C value is 3 into 10 to the power of 8 divided by lambda minimum is 0.45 into 10 to the power of minus 10 joules, right? That is equal to 27.6 into 10 to the power of 3 electron volts, right? So first we have to clear this calculation, we have to complete this calculation, then you will get the answer in joules, okay? That value we have to convert into electron volts, then you will get it as 27.6 into 10 to the power of 3. 27.6 into 10 to the power of 3 electron volt, that is equal to 27.6, because 10 power 3 means kilo, no? You can replace this 10 power 3 with K. So 27.6 kilo electron volt, 27.6 kilo electron volts, okay, right? So we calculated maximum energy of a photon in the radiation, that is we got 27.6 kilo electron volts. Next B, see here. To get photons of energy 27.6 kilo electron volt, electrons of at least 27.6 kilo electron volt must strike the target of the X-ray tube, right? To get the listen carefully, this is what information he is giving. He is asking, what he is asking, from your answer A, guess what order of accelerating voltage is required in such a tube. So what order of accelerating voltage is required means 30 kilo electron volt is the order of accelerating voltage required. But how it is means, he is saying to get photons of energy 27.6 kilo electron volt, electrons of at least 27.6 kilo electron volt must strike the target of the X-ray tube. Hence the accelerating potential should be greater than 27.6 kilo electron volt, or it should be the order of 30 kilo electron volt. 30 kilo electron volt. Okay, right. Next, see here, ma. That is what observe carefully, right? So he mentioned here, that is what accelerating potential. Accelerating potential, right? Accelerating potential should be greater than 27.6 kilo electron volt, or it should be the order of 30 kilo electron volt. 30 kilo electron volt. Okay, right. See here, ma. So this is what accelerating voltage. Accelerating voltage. Okay, right. And next thing is, see here, that is what I am saying. Next thing is here, that is we calculated. See the next problem, problem number 24. See here, in an accelerator experiment, on high energy collisions, in an accelerator experiment on high energy collisions of electrons, high energy collisions of electrons with positrons, a certain event is interpreted as annihilation of an electron positron pair, of total energy 10.2 billion electron volt. 10.2 billion electron volt, billion electron volt into 2 gamma rays of equal energy, full stop. What is the wavelength associated with each gamma ray? What is the wavelength associated with each gamma ray? So here 1 billion electron volt is equal to 10 to the power of 9 electron volt. Okay, see here, I will repeat once again the problem. You please be concentrate. In an accelerator experiment, on high energy collisions of electrons with positrons, a certain event is interpreted as annihilation of an electron positron pair of total energy 10.2 billion electron volt into 2 gamma rays of equal energy. 2 gamma rays of equal energy. Okay, right, full stop. What is the wavelength associated with each gamma ray? The question is, what is the wavelength associated with each gamma ray? And billion means, you know the value, no? It is 10 power 9. It is 10 power 9 electron volt. Right, see here. First, energy of the 2 gamma rays is equal to energy of electron positron pair. Energy of 2 gamma rays is equal to energy of electron positron pair. Am I right? According to the question, see here. That is equal to 10.2 billion electron volt. So that is equal to 10.2 into 10 to the power of 9 electron volt. Next, therefore, energy of each gamma ray photon is, just, it is divided by 2, that is what, 5.1 into 10 to the power of 9. 5.1 into 10 to the power of 9 electron volt. That we are converting into joules. You know that 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules, right? So here 5.1 into 10 to the power of 9 into 1.6 into 10 to the power of minus 19 joules is equal to 5.1 into 1.6 into 10 to the power of minus 10 after completion of mathematical process, right? Minus 10 joules. But you know, E is equal to h nu, that is equal to hc by lambda. E is equal to h nu, that is equal to hc by lambda. Hence wavelength associated with gamma ray is, is lambda is equal to hc by E. Lambda is equal to hc by E, and you substitute these values, h value, c value and E value. That is what I can say, ma. Here h value is 6.63 into 10 to the power of minus 34 joule second, right, into c value is 3 into 10 power 8 divided by E value is 5.1 into 1.6 into 10 to the power of minus 10 meters, right. So finally, if you complete this division, this multiplication and this division, if you complete this mathematical calculation, you will get final value, that is what wavelength associated with gamma ray is 2.436 into 10 to the power of minus 16 meters. 2.436 into 10 to the power of minus 16 meters, right. Okay, this is what wavelength associated with gamma ray, wavelength associated with gamma ray, right. Okay, dual nature of radiation and matter. In this class we discussed 3 problems, 22, 23 and 24, right. In 22nd problem we calculated E by M value, based on the given data, right. So they have given potential difference, potential and radius of the circular orbit and magnetic field 2.83 into 10 to the power of minus 4 Tesla. And here, you know, the gain in kinetic energy of an electron when it is accelerated through V volts. So we are equating the energy, so that we are writing expression for speed, okay, square of the speed, V square, that is like equation number 1. Then as a magnetic field provides centripetal force to the electron, right, so we are writing, this is what you know, from magnetic effects of current chapter, EVB is equal to mv square by r. Here also we are writing V square as a subject, right, just by squaring these terms. This we are getting from here. This is like equation 2. From equations 1 and 2, so we are equating these two. LHS is same, so we are equating right hand side. Then finally we are getting, this is like a formula or relation for E by M. So by writing or by substituting the given values, V value, B value and R value in SI units, right, because while substituting numerical values in the given formula, all the physical quantities must be in one system of unit. Generally, while solving board related problems in board syllabus, we took SI, okay. So it is what finally we are getting here, E by M value as 1.73 into 10 to the power of 11 coulomb per kg. Next, afterwards in 23rd problem, right, he is asking to find the maximum energy, right. In 23rd problem he is asking to find the maximum energy, right, the maximum energy of a photon in the radiation, okay. So we calculated by having that value given lambda minimum, and with this formula E maximum is equal to H nu maximum is equal to Hc by lambda minimum, we calculated energy as a 27.6 kilo electron volt, right. So based on that you can answer for B or 2, whatever it may be. Suppose if it is A means it is B, right. So it is like it is A means it is B or 1 or 2, whatever it may be, okay. So you just feel this one as okay, 2, because there are 2 things, no, A and B, right. So this is A means this is B, okay, or 2. So to get the photons of energy, this much of energy, right, so we need that accelerating voltage, accelerating potential should be greater than these values and the order of this 30 kilo electron volt. Next, 24th problem, in an accelerator experiment, right, on high energy collisions of electrons with positrons, a certain event they have given and asking to find what is the wavelength associated with each gamma ray. Okay, first we are going to calculate the energy for 2 gamma rays that already given. This we are not calculating, sorry for that. So they have given 10.2 billion electron volt and we are writing in terms of electron volt. Then energy of each gamma ray you can just divide 2 and this is the value. And next you can find out, that is what E is equal to h nu, that is equal to hc by lambda. Here you write lambda as a subject, that is hc by E, and write down the values, right? After completion of that, finally you will get wavelength as 2.436 into 10 to the power of minus 16 meters. Okay, right. Thank you. In our next class we will continue with 25th problem.